just another example to hopefully help you realize that there are multiple ways to write a series. All right. In this situation, we are looking to write a general term for the series 1 minus a quarter plus a ninth minus a 16th plus blah, 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 blah. Okay. So we see with our first situation, we have n beginning at 1, and we have the alternating happening that we want. And the question is, what should go into the denominator? All right. Well, we want 1 over 1 squared, and then 1 over 2 squared, and 1 over 3 squared, 1 over 4 squared. All right, the brain is quickly picking up on the perfect squares in the denominator. All right, so it seems like we need n squared in the denominator. All right, so let's start with n squared and see if that will actually be good enough. All right, n starts at 1. Okay, so we have 1 over 1 squared, and it's going to be negative 1 to the 0 power, so it'll be positive, and that checks out. And then n will bump to 2, so now we have negative 1 to the first power, which gives us the negative that we want. And then we have 1 over 2 squared in the denominator, so we get our 1/4. And the next term is going to result in 1/9 being positive, and the term after that, negative 1/16. So it does seem like n squared is what we're missing for that example. All right, for the second term though, rather the second sequence, we're not starting at 1, we're starting at n equals 0, all right? So it doesn't seem like n squared is going to work right here, because right away we're going to have 1 over 0 squared, and we know that we can't divide by 0. So we need something more than just n squared in the denominator, all right? We need our first term to be 1 over 1, all right? So, but if our first term is producing a 0 in the denominator, what should we do to n? Yeah, we should add 1 to it. All right, so we have n plus 1. Okay, so now when we plug in 0, we have 1 over 1, which is what we're looking for. But then n bumps up to 1. When n bumps up to 1, we have negative 1 to the first power, all right, and that will be negative. But in the denominator, we have 1 over 2. We want 1 over 4. We need those perfect squares. So we're going to have to actually square that binomial. And that's actually what we have happening in the third term as well. We're squaring the binomial. The question is, what value of n should we start with, right? Well, our two most common ones are 0 and 1, right? But we can see that if n is 0, we're going to have negative 2 squared, which is 4. We want 1, so that doesn't help us out. If n is 1, if we were to do that, all right, we would have negative 1 to the first power. That's a negative value, but we want a positive value, so 1's out. If we go to 2, well, now we're dividing by 0, so 2's out. What about 3? All right, well, that gives us negative 1 cubed. That's negative, but then we have this negative here as well, so that makes it back to positive. 3 minus 2 gives us 1, so we end up having positive 1. So that does seem to work. Let's just check with 4 real quick. Does 4 produce this? Well, we have negative 1 to the fourth, which is positive 1. So 1 times, but then the negative 1 right here, so we do get the negative sign. And then down here we have 4 minus 2, which is 2, but we square it, so we get the 4. And so yeah, it does seem like 3 is the value that we want to start with.